In this lesson, we are going to be dividing rational expressions. So when we look at number one, we're dividing two fractions, right? These, if you look at our numerators and our denominators, they're both monomials, so one term. Nothing's being added or subtracted. When you remember dividing fractions, how do we divide fractions? We really multiply by the reciprocal. So go ahead and copy that down as multiplying by the reciprocal. And then once I do that, they are the same problems as our video from yesterday. So I'm still going to reduce my numbers first. And then I'd look to reduce my variables. I'd have a c squared and a c squared that reduce to 1, a d and a d, a p and a p. Lots of things are canceling here, right? And then an s, and then this would be 1s. So when I reduce and I multiply across the top, I get 4s over 1, which would be my answer. So now number 2, just to try to make it a little bit more complicated than yesterday, I wanted to show you another way they could write this. When we have a fraction divided by another fraction, they could write it like this. Don't be confused by that. It's the same as writing it like this. So when you see one written as number 2 is in your notes, you can write it out like this, and then it'll seem a lot simpler, and the problem doesn't look as hard. I think number 2 looks kind of hard until you write it out this way. So again, for this one, I would know that I'm multiplying by the reciprocal. So I'm gonna always keep my first fraction the exact same. That one never gets flipped. It's always this is what you're dividing by that you are taking the reciprocal of. So then this would be 20t squared over 9r cubed s. So now as I cross cancel, I'd have a 3 goes into 9 3 times, 5 goes into 24 times, the t squared and the t to the 4th, the r cubed and the r squared, and the s and the s cubed. So now as you multiply across the top, you would get 4s squared divided by 3rt squared. And we always write those answers in descending order. So now, moving on, number 3, you'll notice we have trinomials as well as monomials in this problem. So again, when we are dividing, we will multiply by the reciprocal. So you're going to flip that. Before I do any canceling at all, I'm going to factor my trinomials. So I look at my top left numerator, and I'm going to try and see if there's a greatest common factor, which in this case there's not. So I'm looking for factors of 16 p squared and factors of 1 when added together make negative 8. I know they both have to be negatives, and the only factors of 1 are 1 and 1. So I'm going to try and find what factors I would get of 16 that could add to make 8. And I'm going to say that's 4 and 4. So 4p and 4p. Foil that out, and you'll see that it does get us back to the original trinomial. The one thing you might be wondering about is if you want to write this as 4p minus 1 quantity squared. In our work, we don't want to do that because we're going to end up canceling some things. So just in our answer, if that's still there, we would do that. In my denominator here, I have 14p to the 4th, which is a monomial, so I can't factor something that's a monomial. There's nothing to break down, so we leave that one alone. And then I go to my next fraction. I have 7p to the 5th in the numerator. Again, it's a monomial, so I'm not going to touch it. In my denominator, I have a trinomial, so I know I'm going to try to factor this. And I don't really have factors of 4. Could be 2 and 2 or 1 and 4. And I would normally try 2 and 2 first, but I'm going to be really smart right now. I know my goal is to cancel things out, isn't it? So wouldn't it be smart for me to think that one of the factors is probably 4p minus 1? So I'm going to actually try 4p and 1p. And then when I'm looking at my factors of negative 2, I'm going to try negative 1 and positive 2, because I wanted to make that factor look the same as my others. And this is just me being a smart guesser as to how this would work. When I FOIL this out, I would get on the outsides a positive 8p, and on the insides a negative 1p, so it actually does factor right. So when I go to cancel now, I'm able to cancel this 4p minus 1 with this 4p minus 1. And then I look at my monomials, my 7 and my 14 can reduce, and my p to the 4th and my p to the 5th can reduce. So I end up with p times the 4p minus 1 in my numerator. And Some people would maybe try to write it like this. We prefer it over here. It's technically not wrong on that side, so it would be okay to write it like that. And then in my denominator, I'd have a 2 times p plus 2. Nothing else in this area reduces, so that's my final answer. I'm going to let you guys try number 4. So you're going to take out a greatest common factor if you have one, and then factor them and see what cancels. So please pause the video, do number 4, and then check your answer with mine. Again, we're multiplying by the reciprocal. In this one, you should have taken out a 2. And then in my denominator, I have d plus 2, d minus 1. In my numerator over here, I have d plus 2, d plus 1. And then nothing reduces in my denominator here, so it stays d plus 3. So when I go to cross cancel, my d plus 3's cancel, my d plus 2's, and that looks like all I can cancel. So I would have a 2 times a d plus 1 over d minus 1. Now, some students are going to be wondering if we could possibly take a negative out to make these two the same, right? The d minus 1 and the d plus 1. This is a positive d and a positive d. So they aren't opposites. That's not going to work for this problem. This is as far as I can go. So that's my final answer. 5 and 6 then. 5 is very similar to 4. Again, we're going to multiply by the reciprocal, so you guys go ahead and copy that down. And I noticed that in my first fraction I have k minus 3, which is a binomial, but it doesn't have a greatest common factor, and it doesn't have a squared, so that's as far as I can reduce it. Same with that k plus 1 in the denominator. When I look at my other fraction, I have 1 minus k squared. This one is one people often miss when they're factoring, because this is a difference of two squares. It is 1 plus k, 1 minus k. And the order matters here. My perfect square that I have first is a 1, so that's why the 1's are first, and then my second perfect square is the k squared, so those should be your last term for both. So make sure you have it in this order. And then when I factor my denominator, I would have k minus 3, k minus 1. So now when I'm looking at what I can cross cancel, I have k minus 3, k minus 3. K plus 1 and 1 plus k, aren't these the same thing? I can change the order and they'd be the same, aren't they? So those can cancel. Now, when I look at my 1 minus k and my k minus 1, those aren't the same. But again, take a look at the signs. This is a positive k, negative k. Negative 1, positive 1. So I can choose to take a negative out of either one of these. And then, when I look at the signs again, I have a positive k, negative 1, negative 1. So they do end up being the same. So now I can reduce them. And all that's left through all this work is that negative 1 right there, which ends up being my answer. And again, if these are confusing to you, make sure you take some notes and watch it more than once. But if you have questions, you can always ask me tomorrow also. Last one we're going to do together is number 6, and I want you to try this one. Remember that this is written confusing for you, so pause the video, write it out in a nicer way probably, and then see if you get the same answer as me. So as you did this, hopefully you rewrote it like this, which then led you to write it as a multiplication. Here's what I got when I factored. So you can see I reduced each one that I could. And then this is my work for canceling. And then that is my final answer. If you have any questions, make sure you let me know.